Right, so last section, or last part of the section we're going to look at for this week is 2.2 part 3. And we're going to start off by looking at how do we deal with problems where we have multiples of 30, 45, or 60. So maybe an angle like 120. Okay? That's a multiple of 30 and 60. Those angles we can work with almost just as easy as the ones we did yesterday. The key is remembering the coordinates for the 30, the 45, and the 60. So we're still going to be using the same triangles, except it's going to be in different quadrants. You're going to see that not much really is going to change. And we're going to just start off with an example right away. There's really nothing new I need to explain. So the first thing you want to figure out is the angle they're giving you. First of all, is it a multiple of 30 or is it a multiple of 45? Okay, that's kind of step one. So they want us to find the 6 trig functions of 135 degrees. Is that number a multiple of 30 or is that a multiple of 45?
45.
It's a multiple of 45. And do you remember, well actually we'll get to that in a second. It's a multiple of 45. Right, so the first thing we'll do is sketch it as accurate as we can on the unit circle. So this is 0. This is 90. This is 180. Can anyone tell me roughly where 135 is? Yeah, Raymond?
Would it be in the middle of 180 and 90 degrees?
Yeah, it's exactly in the middle between 180 and 90. Okay, the 3 choices you're going to have for where to put the dot today, it's either going to be right in the middle, closer to one of the axes, or closer to the other axis. Okay, in this case, it's right in the middle. So that's 135. Make a triangle. I'm going to draw that same triangle a little bit bigger over here. So we know that 135 is a multiple of 45. Because it's a multiple of 45, that means it's going to be my 45, 45, 90 right triangle. We're not going to be using 30 and 60 degree angles in this one. Another way you can kind of think about it is ask yourself, how far is it from 90 to 135? That tells you how big this angle is right here. How many degrees is it from 90 to 135? Yep.
45.
Good. Yep, it's 45. Well, if this part's 45, then this part has to be 45 as well, because the quadrant makes a 90. Okay, so that's a 45 degree angle right in the lower right part of the triangle. As all the angles add up to 180, that's 45 degrees at the top as well. And Ben, do you remember in the 45, 45, 90 triangle, each side is the same length. But do you remember what the length is? Anyone help them out? What's the length in the 45, 45, 90? There's 3 numbers you got to remember for this. Okay? Yep. So the base is square root of 2 over 2. And how about the height?
The same.
It's the same. So those are the lengths of each side. Now, what we have to remember is this is in quadrant 2. So we're going left and then up. So anybody have a guess at what the coordinate for 135 is going to be? Jade?
Negative square root of 2 over 2.
Yep, so negative square root 2 over 2, because we went left and then,
And then just positive square root 2 over 2.
good, and then positive square root 2 over 2. That's the coordinate for 135. And that's basically all that's different that's going to happen today. Sometime you'll have a negative in front of the x. You could have a negative in front of the y, or you could have a negative in front of both, depending on the quadrant. All right, so let's go through all 6 trig functions. So, Dom, what's my sine here?
I don't remember.
Do you remember the definition of sine? Sine is equal to what letter? Not sure. Raymond, can you help him out?
It would be square root of 2 over 2.
Yep, and in this case, if you mix them up, it would come out wrong because one's negative and one's positive, but you picked the right one, the y value. Square root 2 over 2. And there's my sine. James, how about my cosine?
That's negative 2. No, square root of 2 over 2.
Yep, cosine is negative square root 2 over 2. And Colby, how about my tangent?
Negative 1.
Yes, you got to take the y value, which is root 2 over 2, divide by the x, which is negative root 2 over 2. So you're dividing two numbers that are opposites. Whenever you divide opposites, you get negative 1. All right. And Lacey, once I have the 3 on the left, what do you do with each one of them to get the 3 on the right?
I'm sorry, what did you say?
Well, once you have the 3 on the left, what do you do to get the 3 on the
Oh,
right?
you flip them.
We flip them. Okay, we're going to take each one and flip it. So Jacob, can you tell me my first step to getting the cosecant?
You flip the 2 square root of 2.
And what would you get when you flip it?
2 over square root of 2.
2 over square root of 2. All right, then we go on and fix that so we don't have a square root in the bottom. So Autumn, what does that simplify to?
It simplifies to square root of 2.
Just the square root of 2. Yep. We've done that a few times at this point. All right, and Jess, how about my secant?
Would that just turn into negative square root of 2?
Yeah, because sine and cosine are basically one's positive and one's negative, but other than that, they're the same thing. So this one's going to be negative square root of 2. All right, and Mateo, how about my cotangent of 135?
Flip.
Yep, we do flip. Which one do we flip?
Tangent.
Good, we flip the tangent. What's my tangent in this case?
Your tangent is minus 1.
Yep, so what do you get if you flip minus 1?
Would it just be like 0 over 1?
Well, what's in the bottom right now? We don't have a 0 under that. We could put something if you want to make it a fraction.
Would it just be minus 1 again?
It'd be minus 1 again, right? Because that's minus 1 over 1 if you want to think of it that way. When you flip it, it's 1 over minus 1. That's still the same thing. Minus 1. All right, so there's our 6 trig functions for 135. That's the only problem today. I'm going to go to all 6. Every other problem is going to be like what you're going to see on the test. They'll give you 1 trig function to find. But any questions on doing all 6 here? All right, so let's try this one. Find the cosecant of pi divided by 4. Katrina, do you remember what pi divided by 4 is if we change to degrees?
It's 45.
It's 45. That's a 45-degree angle. So hopefully at this point, we might not even need a sketch. We can just remember the coordinate. Ava, do you remember the coordinate for 45 degrees?
Square root of 2 over 2. Square root of 2 over 2.
Good. Square root 2 over 2. Square root 2 over 2. Both positive because 45 degrees is in the first quadrant. Now they only want one answer, just the cosecant. So Vivian, the cosecant is which one? Flip. I know they're the same this time, but we should know which one it is.
X.
Can you say it again?
Is it X flipped?
That would be the
Oh,
secant.
then it's Y flipped.
It's y flipped. So if we take y and we flip it, okay, we get that. And Dawn, if I clean that up, what does that turn into?
Square root of 2.
Yep, it's going to turn into 2 times the square root of 2 over 2, which is just square root of 2. And that's it. So that's what the test problems are going to look like. There'll be a spot that says type the coordinate, and then there'll be a spot that says to type the answer. If you have a little bit of trouble on Edulastic trying to type the square root and get the number under the root and then make it look like this, that's something I can help you with on the test because you've never done that before. So maybe even tomorrow I'll make a practice problem on Edulastic and just have you practice typing a number in that looks like this. And if you can't do it, I'll help you. All right, let's try this one. 225. Okay, so first step, we got to figure out the coordinate. But it helps to know if that's a multiple of 45 or 30 first. So Pete, is that a multiple of 45 or 30?
45.
Yep, it's a multiple of 45. It can't be a multiple of 30 if it ends in a 5. That's not possible. So we know it's 225. We have to figure out roughly where that's going to go. And our choices are right in the middle, between 180 and 270, closer to 180, or closer to 270. So Olivia, where's the 225 going to go in this case?
In the first quadrant, like in the middle.
So it's going to go, so this is, let me number the quadrants. Which quadrant is it going to go in?
The third.
Yep, it's going to be in the third quadrant, and then closer to 180, closer to 270, or right in the middle.
Closer to 180. In the middle.
Yeah, in the middle. The 45s are always right in the middle. The 45s are always right in the middle. The only ones that aren't in the middle are the 30s and the 60s. They're closer to one or the other. So 45 goes right in the middle. So there's my triangle. Leave that. And Aiden, how long is each side in the 45, 45, 90?
Square root of 2 over 2.
Yep, they're both square root of 2 over 2. The only thing we have to be careful about is we are in the third quadrant. So, Angelina, what's going to be my angle for 225?
The angle?
Yep. My coordinate, I'm sorry, my coordinate.
Okay, I figured, I just wasn't. It's negative 2 over, square root of 2 over 2, negative square root of 2 over 2.
Yes. Anytime you're in the third quadrant, both your x and your y are negative. All right, so then my sine in this case is what? So what's the definition for sine? Sine equals what letter?
It's negative square root of 2 over 2.
And which one did you pick?
The Y.
The y, correct. So negative square root 2 over 2. Questions on that one? All right, Let's try cosine of 7 pi over 4. So Dominic, how do I convert that to degrees?
Times 180 over pi.
Yep, so multiply by 180 over pi, very good. Pi's are going to cancel. I'm going to get 7 times 180 divided by 4. That's 315 degrees. You probably notice a pattern at this point. We're basically doing a 45-degree angle in every quadrant. We're 45, 135, 225. Now we're doing 315. You're welcome. All right, so let's mark up the diagram and see where that's going to go. I know that's 270, and I know 360 is all the way around. So Raymond, where's 315 going to go? Closer to 270? Closer to 360? Right in the middle. Right in the middle. All right. So again, it goes right in the middle because this is a multiple of 45. It's 45 times 7. And now we're going to label each side of the triangle. Okay, we haven't written the coordinate. All we've done is labeled how long each side is. But now we have to take into account the fact that we went down. So James, what's my coordinate for 315?
For 315, square root of 2 over 2 negative square root of 2 over 2.
Right. Any coordinate in quadrant 4 is going to have a positive x and a negative y. And Colby, now that we have our coordinate, can you tell me the cosine?
Square root 2 over 2.
Correct. Square root 2 over 2. And we're done. Any question on that? So at this point, I'm not going to draw all the triangles, but we've done all of these. All the dots in black are the 45s. We've also done 0, 90, 180, and 270. Those are all the different coordinates we've gone through so far. And yesterday, we did the 30, which would be about here, and the 60, which would be about there. Now what we're going to look at is doing the 30 and the 60 in the other quadrants. I'm not going to go through every one of them. But that's basically a complete diagram of everything we've gone over. All the black dots are the 45s. All the green dots are the 30s and the 60s. And all the red dots are the quadrantal angles. Right? So that gives you 16 different dots around the circle that I could ask you about. And you have to find the coordinate first, and then find the trig function they're asking for. All right, so let's try some of the green dots. Okay, tangent of 120. Okay, so first thing we want to ask ourselves, multiple of 30 or multiple of 45? Lacey, is this one a multiple of 30 or 45?
30.
It's a multiple of 30. It's 30 times 4. So we draw our diagram. This time it's important that we get it right because the two numbers here are different. One is root 3 over 2. The other one is a half. We have to get them in the right order. Okay, so 120. 3 choices. Right in the middle. Closer to 90 or closer to 180. Jacob, where's 120 going to go?
30 degrees past 90.
Yeah, just 30 degrees past 90. It's just a little bit past 90. So it's definitely going to be closer to 90. Now, if I make my triangle like that, and like that, we should have a good idea of which side is the short side and which side is the long side. In this case, the short side is on the bottom. And Autumn, do you remember in the 30, 60, 90 how long the short side is?
1/2.
Yep. Good. Short side is 1/2. And Jess, how about the long side?
Square root 3 over 2.
Good. Square root 3 over 2. So now we can write our coordinate, but just make sure we take into account that we're in quadrant 2. So we went left and then up. So Jaden, could you give me my coordinate for 120 degrees?
Negative 1/2, positive.
Hey, can you just shut that for me? Can you just shut that for me? Yeah, sorry, go ahead.
A positive square root 3 over 2.
Very good, thank you. Negative 1/2, positive root 3 over 2. Any question on the coordinate? Now it's just like every problem you always do. Tangent is y divided by x. The denominators cancel out, and all we're left with here is square root of 3 divided by negative 1, which is negative square root of 3. Any question on that one? All right, so you notice there's 8 green dots we can do. We're not going to go through all 8 of them. Maybe we'll pick like one more. I'll let you guys pick. Do you want to do secant of 690 or cosecant of negative pi over 6? Yeah,
You 690.
the 690? All right, let's do that one. All right. What's the first thing we should do with the 690? It's already in degrees, so we don't want to change the degrees. Yep.
Subtracted by 360.
Yep, let's subtract 360 from it. All right, and I get 330. Okay, 330, multiple of 30 or multiple of 45?
30.
It's a multiple of 30. It's 30 times 11. Okay. So 330. So 270 is at the bottom. 360 would be all the way around. How about Mateo? Is 330 right in the middle of these two numbers? Closer to 360 or closer to 270?
Closer to 270. Oh wait, no. Closer to 360.
Yeah, it's only 30 away from 360.
Yeah.
All right, so it's going to go more towards 360. Make your triangle. The vertical side, that's your short side. And the short side is always a half. The long side is always root 3 over 2. All right, now we're ready to write our coordinate. X is positive because we went to the right. Y is negative because we went down. And they want to know the secant. So which one do we flip to get secant? Pete?
X.
Yep, good job. We're going to flip the x. And that's going to give me 2 root 3 over 3. When we flip it and fix it. 2 root 3 over 3. Right, so you're going to see these same kind of answers coming up over and over. Root 3 over 3, 2 root 3 over 3, maybe negative. Right, but those, we're going to have a limited amount of answers that we get when we do these. Any questions on that? All right, so I have the same diagram that I basically showed you. It looks a little more confusing because they put every triangle and every coordinate on it. But the reds are all the 45s. The green are all the green and the blue are all the 30s and the 60s. And basically, as long as you know the 3 coordinates that I just circled, everything else is just a mirror image of one of those coordinates, meaning a negative in front of the x, a negative in front of the y, or a negative in front of both. Okay, but those 3 coordinates we learned yesterday is all you need to do any of those 16 different points. Okay, questions on that? All right. So let's take a look at this. So everything we've done so far has always been on the unit circle. So let's pretend that this circle right here, this is my unit circle. And this is what we've been doing all week. Now, let's pretend that we have a bigger circle. How much bigger, I don't know. But bigger. So let me draw in this line. This is 1. Okay, that little section from there to there. This section in red, we're going to call R. It's a radius of a bigger circle. And we can put a triangle, just like we've done before. If I take, let me make that black. This is the triangle that you guys have been doing all week. That's a bad color there. Let me do green. Let's put that. Trying to move it without it coming apart. Out. Okay, so we got our triangle in green, and there's the little triangle that we draw. Sometimes it's in quadrant 1, 2, 3, whatever quadrant it's in. All right. Here, let's do this triangle in, I don't know. Let's do that color. Here's our triangle, but now it's a bigger triangle. Right? What we want to do is basically turn this problem back into what we know how to do. So instead of having to work with the big triangle, we would rather be able to work with the smaller one. So let's put this one over here. Let's break the triangle into pieces and move one piece at a time, or we can just hit undo and put the triangles back where they started. Okay, that works. So now I have my 2 triangles. One's part of the bigger circle, one of them's part of the smaller circle. Looking at the black triangle, what was the radius, or what's the hypotenuse of the black one? Yeah? 1. What's the hypotenuse of the green one? Yep, it was R. All right. So let's kind of make a little thing here. Let's call it original, and then the new one. Originally, we're used to working with a radius of 1. The new one has an R. And you know what? Actually, it might even be easier if I reverse the column. Sorry. It doesn't really matter, but I think visually it'll make more sense. So the new one is an R. Originally, we had a 1. How can you change R into 1? That's what we basically want to do. We want to change R back to 1. We don't want it to be R. We want it to be 1. And if you're not sure, think about if you had, let's say the radius was 3 in my new circle. And I want to change it back to a 1. So basically what I'm doing is I'm kind of taking this green triangle and shrinking it down. Like this. I'm shrinking it down. And when I shrink it enough, not that much, but when I shrink it enough, I can turn it back into this other problem. Okay, I'm trying to shrink it back down. I'm trying to scale it down. Does anybody know what you could multiply 3 by to change it back into 1? Yeah?
1/3.
1/3, or basically divided by 3. What if you had a green triangle that had a radius of 5? What could you multiply, or what could you divide 5 by to shrink it back to 1? Yeah?
You could divide by 5 to multiply by 1.
Yeah, you could divide it by 5 to turn it into 1. What if your radius was 6? What could you divide it by to turn it into 1? Yeah?
You just keep dividing it by itself.
Yeah, you divide it by itself. So if your radius is r, divide it by itself, and it turns into 1. Bless you. Now, in the black triangle, we had 2 other sides as well. We had x on the original, and we had y on the original. If we divide one side by r, we have to divide, actually I should put these here. Let's see, yeah. If we divide one side by r to turn it back into the original, we have to divide everything by r. Because if you think about making a shape smaller, you can't just make one side of the shape smaller. You have to make all sides of the shape smaller. So if we divide r by r, we get 1. We also have to divide x by r, and we have to divide y by r. And what that does is it takes the bigger triangle, and it's like a scale factor. It scales it down to make it smaller. How small? It makes it so the hypotenuse is exactly 1. And by scaling it down to a problem where the hypotenuse is 1, we've changed it back to the kind of problem we know how to do. Now, the only thing we have to look at is what just happened right here. X turned into x scaled by r, scaled down by the size of r. Same thing with y. Y turned into y divided by r. So we're going to put up the same formulas that we had on Monday, except everywhere we had an x, we're going to change it to x divided by r. Everywhere we had a y, we're going to change it to y divided by r. And this takes a triangle that's too big, scales it down and makes it smaller, so we can basically use the same formulas we had before. So, Dawn, what was y? Y has always been what? Never mind. Sine is y.
Y.
I didn't mean to say that. Yeah, sine is y. We're going to change y to y divided by what?
That would be
What letter?
cosecant.
So what letter?
What letter?
Yeah, y turns into y divided by,
X with tangent.
so y was the new one, but we're trying to change it back to what we had originally by making it smaller.
Oh, so yeah, one letter.
It turns into y divided by r. Okay, x turns into x divided by r. And what about tangent? What was the formula for tangent originally? Yes?
Y divided by.
Tangent was originally y divided by x. Well, do the same thing in that formula. Replace y with y divided by r. And replace x with x divided by r. What happens if you divide those two fractions? Yeah, Ava?
Cancel out the r's.
Yeah, the r's just cancel out. And you end up with exactly the same thing that we've always had for tangent. Okay, so again, what this dividing by r does is it takes a triangle that's too big, it scales it down and makes it smaller, so it's exactly the same size as the triangle we've been using all week. And that's why we can use the same type of formulas. Now, what do we always do with the 3 on the left to get the 3 on the right? Yep. Vivian? Flip them. So the cosecant is r over y. The secant is r over x. And the cotangent is x over y. So, Aiden, what was the size of the circle we were working with up until right now? It always had a radius of what? 1. Now don't do this, but just watch me. Watch what happens if you change all the r's here to a 1. You get that, 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 and that. Do those formulas look familiar? They're the same formulas I taught you on Monday. So really, these formulas, if I put it back the way it was, are what I taught you on Monday. The only thing I did on Monday is instead of telling you that this was an r, I said we're always going to let the radius be 1. So I plugged a 1 into all of these formulas for you. And I told you this was y, this was x, y over x. 1 over y, 1 over x, x over y. So Monday's formulas were really these formulas, just letting r equal 1. Now we can let r equal 2, or 3, or 5, whatever we want. Okay, so to do, and r is the radius of the circle. That's how big the circle is. So now to do a unit circle trig problem with this, we need to know 3 things. You need to know your x and your y, that's your coordinate, and you need to know the size of the circle that you're on. You can't just assume that it's a 1. Okay, so that's the only extra thing we have to find, r. Let's look at an example. So they want us to find the sine, the cosine, and the tangent of the coordinate 5, 12. Now the way you can tell that this is not on a unit circle is think of how the coordinates we've worked with all week look. We've had like 0, 1, 1, 0, negative 1, 0. And we've had coordinates with 1/2 in them, root 3 over 2, and root 2 over 2. We've never had a coordinate that's 5, 12. The other way you can kind of think about how you would know that that's not on the unit circle. Graph the point 5, 12. 1, 2, 3, 4, 5. That's 10, 11, 12. 5, 12 would be up there. Imagine that point on the edge of a circle. Is that a circle with a radius of 1? No. 5, 12 is it's on a much larger circle. It's on a circle that large. That's what I need to find. That line that I just drew in is my radius. But here's a hint at how we can find it. How do you think we can find the length of that radius? Yep.
Pythagorean theorem.
Yeah. How long is the bottom side?
5.
5. 1, 2, 3, 4, 5. And how tall is it?
12.
12. So this is going to be your x when you do the formula. This is going to be your y when you do the formulas. And now we just need to find r using Pythagorean theorem. X squared plus y squared equals r squared. Lacey, what's 5 squared?
25.
25. 12 squared is 144. And Angelina, if I add 25 and 144, what do I get?
169.
169. And now to get r by itself, I need the square root. Does anybody know what the square root of 169 is? Yep.
13.
13. So there's my r, there's my x, there's my y. This was the only extra math we had to do to figure this problem out. Now everything else is exactly the same. Just remember those three numbers. In fact, I'll write them down. X is 5, y is 12, r is 13. All right. So let's start with the sine. Anyone think they can tell me the sine of the angle represented by the point 512? Pete?
What did just 12? I think 12.
Yep, 12, that's the first part,
Oh, over R.
which is
13.
13. So remember, the radius is 13 times bigger than we want. It's too big. We want to do this on a problem that's 13 times smaller. Why? Because that would make the radius 1. So we're going to scale everything down by a factor of 13. And then we can use the same types of formulas we've been using all week. So y is 12/13. How about cosine? What would that be? Raymond?
5 over 13.
5 over 13. Again, normally it would have been 5, but it's on a circle 13 times too big. So we're shrinking it down by 13 times. And it's 5/13. And lastly, what about my tangent? Okay,
12 over 5.
that's going to be y over x, which is 12 over 5. And you might think, well, wait, why didn't we scale that down by 13 times? We did. If you scale the top number down 13 times as much and the bottom number 13 times as much, it has no effect on it. You guys saw that when we wrote something like this, and these r's canceled out. That's why tangent and cotangent have the same formula. So that's how you do a circular trig problem on a circle that doesn't have a radius of 1. Basically, just take your x and your y and divide them by the sides of your radius. And that gives you what you need. Any questions on those three? All right. So, up until now, everything we've done has been finding or using a coordinate. I would never ask you to find a coordinate like 5, 12. The only coordinates I would ask you to find are ones on the unit circle. The only way you would ever have to work with a coordinate like this is if I give it to you. Okay, that's the only time you'd have to worry about that. I would give you something like that. But what if we can't find a coordinate? Okay, what if the angle is not a 30 or a 45 or a multiple? Okay, let's say I ask you to find the sine of 13.7 degrees. You can't do that on the unit circle, okay, because we can't find a coordinate for it. So for that kind of problem, we're going to use the calculator. And tomorrow, when we do a review, I'll have the calculators out tomorrow, so you'll be able to try it, get used to how to do it on mine. Or if you have your own calculator, I can help you with yours. So here's an example of a problem that you would not be able to do on the unit circle. Find the sine of 18 degrees. Look at 18. Is 18 a multiple of 30? No. Is it a multiple of 45? No. Because it's not a multiple of either one of those, we're not going to be able to do it on the unit circle. So let me show you how you do it. First of all, Colby, can you just read that to me, that problem?
The sine of 18 degrees.
So the last thing he said is very important. 18 degrees. We're going to do some problems that might be in degrees. We might do some problems that don't have a degree symbol. That means it's radians. So, since we're in degrees, that's the first thing I'm going to check on my calculator. I have to make sure that this is in degrees. Right now, I am not. Okay, my calculator is in radians. So every calculator is a little bit different, but on mine, I have a mode button. And when I press mode, I have an option that says degrees. When I change to degrees, Now it says degrees at the top. I can help you find that button on your calculator, but that's the first step. Make sure you're in degrees. And now just type it in. Sine 18. And the answer is 0.309. And if you notice the way I typed it in, I pressed the sine button, and then I pressed 18, and then I hit enter. On this calculator, it's a little confusing because it's backwards. I pressed sine and then 18. On this one, I have to press 18 and then press the sine button. I get the same thing, but I have to type it in backwards. So you have to figure out on your calculator which way you type it in. Hopefully it's this way on the right, because then you type it in the order you see it. If your calculator works backwards, if you know how to do it backwards, that's fine, but you might want to use one of my calculators instead. All right, let's try cosine of this. All right, so Jacob, can you read that one to me?
Cosine of 356 degrees.
Degrees. So again, I check my calculator, make sure I'm in degrees. Yes. I'm ready to type it in. Cosine 356. Hit enter, and that's it. If you're trying it on your calculator and you got 0.998, then you did it right. Any questions on how I typed that one? And let's do this one. Okay, how about James? Can you read this one to me?
The tangent of 2.4.
2.4 what? Remember, this number here always represents an angle. So it could be these units, or if there's no circle, it has to be what?
I don't remember.
Okay? Radians. So if you type TN 2.4 right now, hit enter, calculator will give you a number, but it's going to be wrong because it's doing it in degrees. So I go to mode, put it in radians. I don't know if you can see it or not, but now I'm in radians. And we're going to do tan 2.4. Okay, and that's negative 0.916. So that's how you do sine, cosine, and tangent. Any question on those three? All right, let's look at the calculator, and now we're looking for cosecant. I know it's probably a little bit hard to see, but does anybody see a cosecant button? Let's go like this. All right, that's the area you want to be looking in. Is there a button there that says CSC? You don't think they see one? No, keep shaking his head no. Anyone else see one? No, there isn't. There's not a CSC button. So the only way to do CSC is to use one of the buttons we already have and do the same thing we've been doing all week. How have we been doing cosecant all week? What do we do first? Yep.
Find y and flip it.
Yeah, and y is which trig function?
Sine.
Sine. That's exactly how you have to do cosecant. You have to find the sine of 247 and flip it. That's the only way to do it. So the way you can type it in on your calculator, just like this. 1 divided by sine 247. That's how you do cosecant. Take the sine and flip it. Now, before I hit enter, is everything good? No? Yep, Ava?
You need to change it so it's in degrees.
Yeah, I'm still in radians. So if I type that in, that's going to be the cosecant of 247 radians. Not what I want. Even though I typed it, that's fine. On my calculator, I can still change the mode as long as I haven't hit enter yet. And exit out, and then hit enter. So it's negative 1.086. And I'll do one more. Secant of 6. Right, so I'm back in radians again. If I was doing this on a test, I'd probably do all the problems that I can in radians first, and then I'd do all the degree ones like this, so I don't have to keep switching back and forth. Okay, but now I'm back in radians. And what trig function do we flip to get secant? Pete?
Cosine?
Good. You flip the cosine. 1 divided by cosine of 6, and there's your answer. 1.041. So that's how you use your calculator to do angles that are not multiples of 30 and 45. And none of these numbers work. Any questions on that? Okay. So that's the homework for tonight on 116. 67 to 81, those all require a calculator. Okay, they're the ones we just did. So these are all ones you type in on a calculator. 83 and 84, I think those are the unit circle trig problems that are on a bigger circle. So you have to find R. And 49 to 57, that's what we did in the first part of the class. Okay, so remember, tomorrow will be a review day. Okay, I'll have the worksheet on Schoology, so you will need your Chromebook to make sure you can access